The next functional group that we will be learning about is aldehyde, okay? And it has a structure RCOH, okay? And the secondary suffix that we use is al, okay? And if I have RCOH and this is the simplest aldehyde and there's only one carbon atom, so methane, 1-al. So E and A are coming, so I'm removing that E, methane, 1-al. Okay, so you can also ignore that one and methanol. Okay, and the common name is very important for this because this is called by the name formaldehyde. This is one of the common names that's used. Okay, sometimes instead of methanol, they just use formaldehyde. So you must know that formaldehyde is nothing but HCHO, the first member of aldehyde group. Okay. Now coming to the next member, CH3, COH, the second member. So in in aldehyde, the carbon atom having the double bond is also considered while numbering. Okay. So over here, it is 2 carbon atoms. So ethane, 1-al. Here I cannot use E because there's an A here. So I'm just ignoring that E. Okay. Now here, it is also called by another name. You can ignore this one also, no problem. But its common name is acetaldehyde. So these common names, sometimes they use directly. So you must know that it is a second member of the aldehyde group. Okay. Now, coming to some bond line structures. So this is carbon, this is O, okay, and definitely there will be an H here. So here CH3, here there will be a carbon, here there will be a carbon. So over here, 1, 2, 3 valencies are satisfied, there will be one H. So carbon atom having the double bond is also considered in numbering, okay. So this is given position 1, 2, 3. So at the second position, we have the substituent 2-methyl. So this is the substituent 2-methyl propane 1-al. Okay, so the carbon atom of the CHO group is also given number. Okay. Coming to the next structure, if I give a structure like this, so there will be a carbon atom here. Sometimes they don't show this carbon, they just show like this. So you must understand that it is the CO group. Okay, so 1, 2, 3. Okay, CH. Now, here. Now, definitely, the carbon atom, that's a functional group, will get first position, second, third, fourth, fifth. Okay, and this is our substituent. And what is the name of that substituent? The substituent is at the third position. So 3, this is cyclopropane. The naming of the cyclo group, I have made a video, okay? Cyclopropane, yes, but because this is a substituent, I cannot give propane, but instead I give cyclopropyl because it's a substituent, okay? And root word is pent. At the third position, what is there? A double bond is there. So 3-ene. And at the first position, we have the functional group aldehyde. Okay. So propyl because it's a substituent. Now coming to the next question. Suppose if I give CHO. So 1, second position. Now ethane 1,2-dial. Right. Similarly, if I have another question, CH3, CH3. If I give a question like this, C double bond O, H. So this is the aldehyde group. So definitely your numbering will be from the functional group, that is aldehyde, to third position. Okay. Now this is our substituent. It's a complex substituent because within the substituent, there's another substituent here. So I have already made a video about this. So our numbering will be the carbon atom attached, the carbon atom that is attached to the main chain will be given number 1, 2, 3, 4. So the second position, we have this substituent, which is complex substituent. We also have another substituent. Right. Now, what is the name of the substituent, which is at the second position? 2 bracket because it's a complex substituent. I've already done a video on naming the complex substituent. Okay. Second position, the connection is from the second position of the main chain. So 2, okay. 3 at the third position of the, so I will number it with bracket. Sorry. 1 dash, 2 dash, 3 dash, 4 dash, just to bring about the difference from the numbering. Okay. So at the 3 dash position, I have bromo, then cyclo, bute, because there are 4 carbon atom, bute. At the 2 dash position, what is there? 2 dash, ene. I cannot write ene because it is a substituent. So definitely I have to go with enyl. For example, if CH3 is the substituent, we write methyl. Same way, 2 dash ene is double bond and yl because it's a substituent. Okay, I close the bracket. At the second position, I have another substituent, that is 2-methyl propane 1-all. I chose to write the name of the complex substituent first because bromo and methyl, the alphabetical order favors bromo first. So that's why I wrote this first. And then at the second position, I have another substituent, which is methyl, and then propane 1-all, because the root word is propane. And at the first position, I have the functional group. I hope I'm clear. Now, coming to the naming, another structure, CCC, I have CHO, CHO, CHO. There are three, filling in the hydrogen, there are three CHO groups. Okay, now here if we number it, okay, so this is given number 1, 2, 3, 4, 5. 2 aldehydes are getting numbers and one has become a substituent. Okay, now you will learn that if there are multiple functional groups, there are priorities. Okay, sometimes we have to treat, if there are 2 or 3 functional groups, all the functional groups cannot be made as a functional group. Some functional groups has to be treated as a substituent. Suppose if in this case we cannot number this CHO, so we have to treat it as a substituent. In that case, we can use the word formyl. So at the second position, I have formyl, pentane, 1,5-dial. Okay, but the IUPAC says that this is wrong because there is a rule. If the functional group has a carbon atom, if the functional group has a carbon atom and are identical, if you see here, all are identical. All are identical. All CHO are identical, right? All are CHO groups. And identical. We cannot leave anyone. We cannot leave them. We cannot treat them differently. All the CH2 group has to be treated in a similar way. I repeat once again, if the functional group has a carbon atom, that is one condition, and are all identical. If you see, all are identical. In such cases, what we do is the CHO, I'm talking about CHO, is called as carbaldehyde. Carbaldehyde. All are treated equally. Okay, for aldehyde, it is called as carbaldehyde. What is the condition? The functional group should have a carbon atom and all of them should be identical, should be the same. So in that case, we number it like this: 1, 2, 3, and we say root word is propane. 1, 2, 3, try carbaldehyde. I hope I'm clear. All of them have the carbon atom. All of them are identical, so we cannot leave them. We have to treat them all equally. Okay, but I'll write another structure to bring about the difference. So if I have something like this, CHO, CH2, CHO. Okay, here I am in a position to number all of them. In this case, what would be the name? Propane 1,3-dial, because I'm able to number both of them. So all of them I'm able to number. I'm not leaving anything. So that's why I'm using dial. But here, in this case, I'm not able to number all of them. Okay. Here, I cannot leave leave any one of them. All should be treated equally because they are all identical and they have carbon atom. Okay. Similarly, to bring about the difference, another one. So 1, 2, 3, 4. CHO, 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 CHO. In this case, what would you do? All of them are identical and all of them have a carbon atom. So I'm not able to number all of them. Anyway, if I number, I'll miss out 2 of them. So I cannot treat them in this way. I have to treat them equally, all of them equally. So What would be the name? Butane. The root word is 1, 2, 3, 4. Butane, right? Butane. 1, 2, 3, 4. I cannot leave any one of them. Tetra. Carbaldehyde. Okay, I hope I'm clear. Similarly, if I have CH2, CHO, CH, CH2, CHO, CH2, CHO. Okay. In this case, here, this CHO is not directly connected to the main chain, if you see. Okay. So if we number it 1, 2, 3, 4, 5. If you see, it is not connected to the main chain directly like this. Instead, there is a CH2. I'll make it a bit bigger so that it's easy to understand. Okay. If you see CH2, CHO, CH, CH2, CHO. There's CH2, CHO. If you see, this CHO is not directly connected to the main chain. Okay, so that is why now it can be treated as what? Now it can be treated as a substituent. The whole thing can be treated as a substituent. So our numbering will start from here. 1, 2, 3, 4, 5. If it was directly connected like this, we cannot treat it as a substituent. Okay, so now in this case, if it is a substituent, name this substituent. Suppose if you have a carbon connected to the main chain like this, CH2, Cl. Okay, so suppose this is at the maybe second position. So you would name it as what? 2-chloro-methyl. Right? So same scenario is over here if you see. It's the same scenario over here. CH2, CHO. Instead of chlorine, what is here? CHO. And this CHO is nothing but formyl group. So it's the same scenario. I'll draw it over here. So it's the same scenario at the third position, CH2, CHO. So instead of chlorine, you have CHO, and the CHO is nothing but formyl because it's a substituent now. It is not, if you see, it's not directly connected to the main chain. So how would you name it? It is 3-formyl methyl. This is how you name it, right? So we will apply this name here. So at the third position, what do you have? 3-formyl methyl. Formyl methyl. What's the root word? Pentane 1,5-dial. Okay, I hope this part is clear. So I've drawn the same scenario. If you have chloro, 2-chloromethyl. And if you have CHO group, it's formyl methyl, right? Coming to another example. If I have a structure like this, and definitely there's a ring and there's a straight chain, or there's a functional group. So definitely this functional group will become the main chain. Okay, so this will become the substituent. We have done it before in the previous video substituent. Okay, so what would be the name? First position, 1 cyclopentane, cyclopentyl because it's a substituent. Cyclopentyl because it's a substituent. Then methane, 1 al. Okay. Now, another if you have a question like this, CH2, CHO, okay. Here, this is the straight chain and this is the ring. Now, if you have to make a choice between which is the root word, okay, definitely this will be the root word because this has the functional group. So always the functional group is preferred for the root word, okay. So this will become our substituent. Okay, now if I number it, definitely you have to number from the carbon atom. Here, 1, 2. At the second position, what do you have? Cyclopentyl, because it's a substituent. This whole thing is the substituent. So cyclopentyl. And ethane, 1 al. And this E I'm removing because E and A are coming near each other. Okay. Now, if the same question, if I'm giving you, or if similarly, if I'm giving you, that would be the right word, COH. Okay. Can you see a difference between them over here? CHO is not directly attached to the ring in the first question, but in the second question, CHO is directly attached to the ring, right? So here, definitely this is the substituent, okay? But here, CHO group is directly attached to the main chain. Okay. Now, in this case, if CHO is directly attached to the ring, so IUPAC has, this is a note that you must remember. IUPAC has said that if the ring is directly attached to CHO, as in the case that I have done now, question number 2. Okay, then also we have to treat it as carbaldehyde. Carbaldehyde. What is the condition? If the ring is directly attached to the CHO. So now in this case, what would be the name? Please take a note of this, okay? Now in this case, what would be the name? Cyclopentane. Obviously, this will be the first position. 1 carbaldehyde, which is the preferred name. Okay, this is the preferred name by IUPAC because they have said that if the ring is directly attached to CHO group, then treat it as carbaldehyde. Okay, similarly, I will give one more example. Question number 3, COH. Here also, this is the ring. Is the CHO directly attached to the ring? Directly attached to ring. Now, in this case, what do we consider? Carbaldehyde is preferred. So this is the first position. So what would be the name? Cyclo. So this is the substituent, yes. So cyclopropane. Although this is a substituent, we consider CHO as carbaldehyde. Cyclopropane 1 carbaldehyde. This is the preferred name by IUPAC. Why? Because CHO is directly connected to the ring. Okay. Similarly, if I have this question, CHO is directly connected to the ring. What would be the name? Both the CHO is connected to the ring directly. So 1, 2, 3, 4, 5, 6. So cyclohexane 1,4 dicarbaldehyde. Please remember, students, here what is the necessary condition? The ring should be directly connected to CHO group. I hope you have taken a note of this. Note what is the condition to be treated as carbaldehyde. This is one of the conditions. Okay. Similarly, if I have this question, this is bromo, this is CH2, CH3. So this is C2H5 group, right? So here also it is direct, CHO is directly connected to the a ring. So 1, 2, 3, 4, 5, because bromo B, if I number the other way also, 1, 2, 3, 4, 5. But I'll use the blue numbering because I will use the alphabetical order. Okay. Now at the third position, I have bromo. At the fourth position, I have ethyl, cyclopentane. At the first position, I have carbaldehyde. Carbaldehyde. Why carbaldehyde? Because CHO is directly connected to the ring, right? I hope you understood. Aldehyde, one more example. If I have this example, CH2, CH2, C double bond O. Now, is the CHO directly connected to the ring? No. So this will be our main chain, root word 1, 2, 3. So here we go as normal. 3 cyclo, this is our substituent. Cyclopropyl. Cyclopropyl. Propane. What is the root word here? Propane. Propane 1 Al. Here we go as normal because the CHO is not directly connected to the earth. I hope I'm clear. Moving on further with ketones. It is RCOR dash. This is the structure where R and R dash are the alkyl groups, can be same or different, and the suffix we use is O. Okay, writing down the name of the first member, CH3, COCH3. Okay, and numbering from here. So there are 3 carbon atoms. So propane, 2 on, because O and E are coming near each other. So I'm removing this E. So it is propane 2 on. Or because this is the first member, propanone. You can ignore this 2 because this is the first member. This has to be the first member, because if this alkyl group is not there, if it is H, then it will become aldehyde. Okay, so this is the first member, and this is one of the commonly used ketone, and common name is very important for this, because mostly for this common name is used, which is called as acetone. What is the common name for this? It is acetone. Sometimes instead of propanone, they prefer to use acetone. So you must know the name of the first member, common name. Okay. Then I have the second member. I just have to increase 1 more carbon atom. That's it. So 1, 2, 3, 4. So butane, 2, all. Sorry, own. Sorry, not all, it's own. Own. Okay, and this O and E is coming near each other, so I'm removing this E. Moving on further, if I have cyclo group here, definitely this will be given first position. Cyclohexane, 1 on. And I'm removing this E because it's a cyclohexane, because all are single bonds. E I'm removing because there's an O here. So I have to remove this E. Okay, and I write it like this. Okay, hex is the root word, and because there is single bonds. Okay, coming to the next question. There are 2 keto groups here. So definitely I'll number from any one of them. 2, 3. In this way, if I number, both of them are getting lowest position. So cyclo, pent is the root word. And at the first and the third position, there is keto group dione. Okay. Similarly, so I hope this is clear. So this is CH2. So this is C1, 2, 3, 1 valency has to be satisfied. This is O group. Okay. So definitely this has the functional group. So 1, 2, 3. So this group, CH, double bond CH2 is our substituent. So this is ethene. Ethene, because as a substituent, I use yle, ethene-yle. So N and Y are coming near to each other. I'm removing this E. So at the, sorry, this numbering is wrong. This should get the second position, right? Because there's a substituent here, right? So at the second position, what is my substituent? Ethene-yle and cyclopropane, propane, because there's all single bonds. 1 own group. Okay. And here I'm removing this E because this E and O are coming near each other. Okay, I hope I'm clear. Own group because it's a ketone. Okay. Now, moving on further with some common names. Sometimes common names are also important. Okay. Common name is alkyl, ketone, because there is alkyl group on either side. Maybe the same alkyl, maybe different alkyl. Okay. For example, I have CH3CO, CH3. This is dimethyl ketone because both are same. Okay. Also, I have CH3, C double bond O, CH2, CH3. Here there's an ethyl group, here there's a methyl group. So definitely I'll write according to the alphabetical order, ethyl, methyl, ketone. Okay. Suppose if I have a ketone, I'm discussing about the common name, okay? CH3, C, CH3, CH, C double bond O, CH2, CH3. Okay, this part you have ethyl. And if you look at this side, here, the connection or branching is from the second carbon atom. So this is isopropyl, right? So what would be the name? Ethyl isopropyl ketone. Okay, I hope I'm clear. So whenever the connection is from the second carbon atom, definitely you will give iso. Okay. Now, coming to the next question. Here also I'm discussing all these names are common names, okay? All these names are common names. Alkyl, ketone. Again, if I give a question like this, CH3, CH, CH3, CH2, C double bond O, CH, CH3, CH2, CH3. Now this, just now we saw the connection is from the second carbon atom, so it is iso. Okay, so 1, 2, 3, 4 carbons are here. I'm just checking this side. Isobutyl, because in common name we consider all the carbon atom, only not just the numbering one. Okay, now if we see this side, carbon, the carbon that is connected, this is the carbon that is connected to the functional group or the main chain. It is, this carbon is surrounded by 2 carbon atoms. So it is given secondary butyl. Secondary butyl. So secondary, instead of 2, 0, I write secondary butyl. So in this case, what would be the name? Similarly, if I have carbon, okay, this is ethyl group. I'm talking about the common name just to make you to identify the secondary, iso, etc. Okay. In this case, this is the carbon, first carbon connected to the main chain, right? So this is surrounded by 2 carbon atoms. So definitely this is what? Secondary. and there are 4 carbons in total. I'm just talking about this group. I'm just talking about this part. In common name, we consider all the carbon atoms. So secondary butyl, and this is the ethyl group. So how do we name ethyl? Secondary butyl ketone. This is the common name. Right? And if we talk about the IUPAC name, definitely we have to number it from the side that the functional group gets the lowest number. We cannot number it from the middle. 3, 4, 5, 6. So at the 4th position, I have, this is IUPAC name. 4-methyl. Root word is hex. There is single bond, so hexane. 3-one. And O and E cannot come together, so I'm removing this. Okay,